So this is 13.3, day 2, and in the last section, or in the last video, we looked at finding trig functions for general angles, and now we're going to move on to a new idea of reference angles. And what reference angles will do is allow us to find the value of a trig function for a specific angle. So it says, if theta is a non-quadrantal angle in standard position, then its reference angle, it's theta with an apostrophe, we call it theta prime, is the acute angle formed by the terminal side of theta and the x-axis. So this angle is acute, which means it's less than 90. It's going to be less than 90. The rules for finding the measures of reference angles for theta between 0 and 360 and theta between, or 0 and 2 pi, either way you want to look at it, are shown below. So if I have a measure in the first quadrant, if we label this is 0 degrees, this is 90, well then no matter what, theta is less than 90. So theta prime, if we're in quadrant 1 and we're not a quadrantal angle, so we're not on the y-axis or the x-axis, theta prime is just going to be theta. So that's always going to be less than 90. If we're in quadrant 2, this means we're over here. If theta, so theta is bigger than 90, so this is theta, then the reference angle has to be the acute angle, so it's this angle. That angle is less than 90. So this theta prime here is going to be 180 degrees minus theta, or if you're given radians, it would be theta prime equals pi minus theta. Oops. So either way, you can be given degrees or radians. In quadrant 3, so your angle would be this one right here, and here's your terminal side. This would be theta. So your reference angle is going to be the acute angle formed by the terminal side of theta and the x-axis. So it's going to be the smaller one of these two. So it's going to be that small angle. So this is going to be theta prime equals theta minus 180 degrees. Or if you're given radians, it's going to be theta prime equals theta minus pi. This one's the only one that differs slightly from the other three. So here, again, your angle is bigger than 90. So your reference angle is this acute angle right here, theta prime. And the measure of theta prime is going to be 360 minus theta. Or if you're given radians, theta prime is 2 pi minus theta. So an important note here. If the measure of theta is greater than 360 or less than 0 degrees, so or we could say 2 pi here, so it could say if theta is greater than 2 pi or less than 0 degrees, then we're going to use a coterminal angle with a positive measure, so it needs to be positive, measure between 0 and 360 to find the reference angle. Again, we could say 2 pi here. So it says, here's an example, it says sketch each angle, then find its reference angle. So 210 degrees, so we'll sketch it. So 210, let's label our 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So 210 degrees would be somewhere in between here, so this would be in quadrant 3. So this is my theta. This means this right here is theta prime. So I'm trying to find the measure of this angle. So I know I'm in quadrant 3. So I'm going to use, according to this, theta prime equals theta minus 180 degrees, because I'm given degrees. So this is theta prime equals theta minus 180 degrees, which in this case is 210 minus 180, which is 30. So theta prime is 30 degrees. Part B, negative 5 pi over 4. So this is clearly less than 0. It's negative. So I need to find a coterminal angle with a positive measure between 0 and 2 pi, because I'm given radians. So I'm going to say negative 5 pi over 4 plus 2 pi. So I want to get a common denominator. So this would be my coterminal angle. So to get a common denominator, I multiply by 4 over 4. And I get negative 5 pi over 4 plus 8 pi over 4, which is 3 pi over 4. So I'm going to give you a little bit of new notation to label your axes using radians, because I didn't give you this notation yet. So this is still going to be 0. 90 degrees will be pi over 2. Where we would have 180, we were going to have pi. Where we had 270, we're going to have 3 pi over 2. And this is going to be, where we had 360 is going to be 2 pi. So now I've labeled this using radians. So 3 pi over 4 is smaller than pi, right? And it's bigger than pi over 2. So it's got to be somewhere over here. So this is theta. The smaller one is what we want. We want this acute angle is theta prime. And that's what we need to find. So theta is in quadrant 2. And I'm given in radians. So according to your chart up there, this is going to be theta prime equals pi minus 3 pi over 4. So theta prime is going to be 4 pi over 4 minus 3 pi over 4. So theta prime equals pi over 4. So that is your reference angle for theta. We're evaluating trigonometric functions. So what we can do is we can use our reference angles that we just learned how to find to evaluate trig functions for any angle theta. The sign of a function is determined by the quadrant in which the terminal side of theta lies. So there's really 3 steps to do this. The first step is to find the measure of the reference angle. So I'm going to abbreviate because I'm running out of room. That's the first step. Step 2, evaluate the trig function for theta prime. Oh, this should say up here theta prime too. Step 3, determine the sign, S-I-G-N, of the trig function value. So hold on a minute. How do I know what sign it gets? Well, I'm glad you asked. So we're going to need to consider the quadrants. So in quadrant 1, everything is positive. In quadrant 2, the only thing that's positive is sine, and so then by default, cosecant is also positive. Everything else in quadrant 2 is negative. So cosine, secant, tangent, and cotangent, those are all negative. In quadrant 3, the only thing that's positive is tangent. So we say tangent, then cotangent would also be positive. And then in quadrant 4, the only thing that's positive is cosine. So cosine, then that would mean secant is also positive. So in quadrant 1, everything's positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. So there's a little helpful mnemonic device that I like to use to remember which one is where we have positive values. Because if you can remember that, then you would know by default the negative values. So the way I like to think of it is if we start at quadrant 1, then we move counterclockwise, all students take calculus. So the A means that everything is positive. All values are positive. S, so your student, so it means sine is positive. So that means in quadrant 2, sine is positive. Then by default, cosecant is positive. In quadrant 3, so that's your take. So T would be tangent. That means tangent is positive, so that means cotangent is positive. And then calculus, C, so in quadrant 4, cosine is positive, which means secant is also positive. So let's look at an example. So find the exact value of each trigonometric function and then include a sketch. So cosine of 240 degrees. So we're going to start with step 1. We're going to find the terminal, where the terminal side lies. So let's sketch 240 degrees. So this is 0, 90, and I'm using degrees because I'm given degrees. If I was given radians, I would label this using radians. So 240 would be in this region over here. So that would be quadrant 3. So this is in quadrant 3. So I'm going to find my reference angle. So I'm going to find this angle, this acute angle. So this is my theta prime. So if this is theta, then this is theta prime. So theta prime, since I'm in quadrant 3, is theta minus 180 degrees. This is 240 minus 180 degrees, which is 60 degrees. So the last part, so I know they asked me for cosine. So in quadrant 3, cosine is, so let's see, is cosine positive? Nope. In quadrant 3, if we look at it, if we use our mnemonic, all students take, so in quadrant 3, only tangent is positive, so cosine is negative. So this would be cosine of 240 degrees equals negative cosine 60 degrees, which if you plug in negative cosine 60 degrees in your calculator, you get negative 1/2. So example B, cosecant of 5 pi over 6. So if you have your unit circle, you'd want to use that to tell you where 5 pi over 6 is. It's approximately over here somewhere. So it's definitely less than pi. So if this is 0, pi over 2, pi, 3 pi over 2, 4 or 2 pi, then certainly this is definitely less than pi because 5 divided by 6 is less than 1. So maybe this is about where theta is. So we want to first find our theta prime. So we want to find that reference angle. So theta prime equals, this is in quadrant 2. So theta prime is going to equal pi minus theta. So it's going to be pi minus 5 pi over 6. So this would be 6 pi over 6 minus 5 pi over 6, which is pi over 6. So we're in quadrant 2, and in quadrant 2, so if we think of that mnemonic, all students, so sine and cosecant are positive in quadrant And so we are given cosecant. So our answer should be positive. So this would say the cosecant 5 pi over 6 is going to be the same exact thing as the cosecant of pi over 6. So you would want to use your unit circle that I showed you in class to find what is the sine of pi over 6. So let's look for the sine of pi over 6. So remember, the sine is your y-coordinate. So the sine of pi over 6, so here's pi over 6. So the sine of pi over 6 is 1/2. But I was asked for the cosecant of pi over 6 would be 2/1, and it needs to be positive. So it's going to stay positive because we were in, because sine and cosine are positive in quadrant 2. You will not be able to use a calculator to do these problems. You will need just to rely on your unit circle. If you have questions about any of the examples that I did in this sheet, please write them down so that you don't forget and then bring them with you.